And now maybe some future perspectives and open questions that hopefully guides us into the discussion is, there is still the question how to couple multiple disciplines, especially when coupling through vector fields. We've touched up on that, on the error elasticity problem. Do you take it apart? Do you look at it once? If you take it apart, at which level do you take it apart, and so forth? So that's definitely unanswered, and there is research needed. I don't think there are readily available solutions yet that you could simply try. So how to derive a consistent approach with different types of uncertainty? I pretty much showed aleatoric uncertainties. There are some options to incorporate some model form uncertainties by applying uncertainties to the points you have, or to the data points. Where to get model form uncertainties is a different question. That's probably also open. Epistemic uncertainties, if you put another Monte Carlo on top of it, might be more complicated, and then you end up with like surrogates of surrogates, probably, or not. I don't know. I would say having a consistent formulation that accounts for all these different types of uncertainty at the same time is currently lacking. At least something that's scalable to the type of problems we have at hand. And then this, in my opinion, is a big point. How to communicate statistical results to decision makers. Here I typically ask, how many of you have taken a statistics class during their undergraduate? Mixed feedback. How many of you enjoyed it? All right, we got one. And now imagine doing the same with a lot of people that have a business degree and lawyers in the same room. I can guarantee you the answer to the first one is probably already zero, at least to the second one, it's zero. Nevertheless, in the end, you have to communicate these results to these people because they are probably the ones signing it or giving out the money. And I'm not overly convinced that showing realizations of pressure distributions is the best way forward, but that's where we are right now. And then the last point here, how to ensure that UQ becomes a tool for engineers. So I think it's well established within research, but I also believe that in order to be used in industry and to be reliably used, it has to become a tool. Like CFD also became a tool that people can take off the shelf, use, and kind of have an idea of what to do with it and what to get out of it. And I believe that UQ, even though there are a lot of great starts and a lot of great opportunities, is not there yet, but it has to become to that, or has to come to that point in order to be a worthwhile addition to the toolbox an engineer has at hand.
Excellent. Thank you very much, Philip. These are very valid questions that we think about on a daily basis. Does anybody have anything to share on these? Because I can certainly start on all of them at once, I suppose.
So I'd certainly say from my perspective, what Philip's shown is very much my experience of using UQ, of basically using surrogates to propagate uncertainties. And as I mentioned at the start of my presentation, they work for well-bounded problems. So things where you have a reasonable level of stability, or the uncertainties are not too big, and you can simulate. Right, surrogates, something else. You have an ability to
simulate what the uncertainties, or
simulate the propagation. So you can simulate the function and simulate the impact of the uncertainties on that function.
Right.
Whatever that function is. So aerodynamic design is one, but for example, that whole approach wouldn't work if you're in the early phases. Well, I don't know my wing area, my wingspan, my wing area. There's too much uncertainty, too much. It's not a uncertainty problem that you would do robust design on. You have to converge before these techniques are useful. And they are useful. And it's the sort of things we do in the late design phases.
So your suggestion then, or like expert input here, would be, before your design converges, try to stay away from surrogate modeling, because you're assuming.
Really great workshop.
Thank you. Because you're only putting uncertainty on top of your uncertainty.
No, you don't avoid using surrogates. You avoid doing detailed optimization in the early phases because you don't have enough information to detailed optimize. So any kind of MDO or optimization in the early phases is a fallacy because you don't have enough information to optimize. You're trying to get the aircraft in the right area of the design to enable you to do these kind of, you have sufficient freedom in your design to be able to run subsequent optimizations. If that makes sense, without coming up against a hard constraint.
Yeah. Okay.
So it's going to add value also to these early phases of the design. You're probably more on the sensitivity side to understand what drives me, and you're able to quantify this instead of fixing something as the optimum. So yeah, I think the general approach will be similar. The outcome will be similar. With respect to optimization, you probably have to reformulate the problem. You're no longer looking for some minimum of drag configuration, but you're probably looking for a maximum of variability or something like this. So I can still see a point there, even though I have not a clear picture yet where to go.
Yeah, I fully agree. That's the work I'm doing at the moment, is using surrogates in the early design for design space exploration, which is essentially human-based optimization. So you recognize that an optimizer, you can use a surrogate, you run optimizer, and they'll tell you that's the optimum design. But every engineer goes, yeah, but I know that hasn't taken account of X, Y, Z. So you use, this is about understanding the design space, understanding your trades, your constraints, how much margin you want to put into your hard constraints, what are your tradable soft constraints. So this is the bit that very difficult to do a numerical optimizer, but this is where architects, engineers, humans will help steer that, because your methods don't contain enough to have a true optimum, if you like. That makes sense.
Exploration, not in the sense of looking for the optimum design, but understanding your landscape.
Exactly.
Yeah. Okay. I'd like to touch upon the last point there. That combined with the title that Philip offered, the UQ being the link between surrogate being the link between UQ and engineering.
You mean the people who wrote down?
Well, it was your presentation, right? So let's not spoil it for everybody. Do you think, are you of the opinion that the main hindrance, or one of the main hindrances in front of using UQ in engineering design, is the added cost of running many simulations? It's a factor. Okay, so what other factors do you think would preclude us from, once we settle the cost? Perhaps some broad strokes.
Again, it relies again on the quantification of the uncertainties. So if they're aleatoric and you've got test measurements, fine. If they're epistemic, then again, it's how much do I believe what's coming out of this, particularly in robust design. Robust design is only as good as if you've done a bad estimation of your epistemic uncertainties, your robust design is rubbish. So, yeah. So there's kind of aspects of what are you trying to do with this. I think as well how, well, that's probably the main ones. I would say most of the challenges that I've come up with in an industry of applying some of these comes to cursive dimensionality, and it comes to automation of our analysis methods and processes. Because a lot of those are not necessarily automated or automatable for parametric sensitivities, for uncertainties and everything else. So those are typically some of the blocking limits today. They are being improved to allow us to do these more parametric assessments as part of every analysis module that we run. Should be run with a more, all models are wrong, I need to test my assumptions and the sensitivity to the assumptions I'm making.
Any further comment or input? Anybody? Yeah, Long.
I have one question. When you do robust optimization, I think you establish the surrogate model and then use the surrogate model to do robust optimization, not updating it in the optimization process, right?
So in the end, it's actually two surrogate models. So there is a surrogate model that takes care of the uncertainty quantification. So that's imagine a fixed design point. So you do have a fixed design, then there is one surrogate which propagates the uncertainties for this fixed design and provides your mean of the drag, for example. And then there is another surrogate that takes this mean of the drag and builds up on it. And that describes the optimization landscape. So the outer bit is a surrogate-based optimization or Bayesian optimization or ego, all the same thing at the end of the day. So you build a surrogate for a quantity that you want to optimize, no matter if drag or mean of drag or statistics of drag. So if you simply would optimize for the drag, you would have one surrogate that queries different designs for drag and builds a model out of it. Here, the outer surrogate defines a shape, and then there is an inner surrogate constructed that tells you how the statistics of this design look, and then you use that to drive the optimization forward. And this one is updated all the time. In the most brute force approach, you can essentially start from scratch all the time. So you do a new design and you build a new surrogate model for the uncertainty quantification. There are some more advanced ways to do this, but in the most simplistic way, it's essentially a nested surrogates, which further increase the cost. There is no free lunch. I mean, doing optimization on top of an uncertainty quantification is even more expensive than just doing the uncertainty quantification, obviously.
Like our video.
Practical questions that come into doing like these kind of more optimizations are, so in your example, you had kind of uncertainty maybe in your operational conditions and you're coming up with a robust solution. If you also had other constraints, say a space allocation constraint, so the thickness of your
it has a thickness constraint.
Okay.
Without showing. So
right.
In the final example, it has.
So deterministic or probabilistic?
That's a question how to understand this constraint.
Yes.
So actually something we're currently trying to look into, how to incorporate constraints and different types of constraints and how to do this. Unanswered yet, in my opinion. If someone has a great idea, please put it forward.
This is possibly the reality when you're doing these, is that not all constraints are known definitively. So you can make them deterministic to make the process work, but in reality they may be uncertain. I'm not quite sure exactly how much space I need to fit in all of my actuators at the point we're doing this.
All the landing gear or whatever. Yeah.
Exactly. So those constraints are, I know it's within this region, and you can set it deterministic to make the optimization easier. But optimization with uncertain constraints as well as uncertain inputs and objective becomes a little bit more complex.
Yeah. Back to your point of robust optimization being rubbish if you don't account properly for your epistemic uncertainty. Perhaps I wonder, like, today in the second session, a lot of the discussion revolved around how epistemic uncertainty propagation methods are best when they're intrusive. We can't open our models up to give intrusive models a go, intrusive propagation methods. But surrogates offer a way to open up your model. So essentially what you do, it's a very, very basic way, but you can inspect the Gaussian process emulator expression any day, and do you think then this is an option to propagate uncertainty through the Gaussian process once you're relatively confident that your surrogate is a good fidelity, captures the main features? Can you then say, okay, now I can apply all my intrusive methods to the surrogate to propagate the epistemic uncertainty? So think back to Alex's talk and Anders' talk, where we were focusing on epistemic uncertainty.
Using intrusive methods like surrogate formulation.
Right.
I mean,
and do you think it makes sense, essentially?
The methods, as long as they are sampling based, they don't care if you sample the real model or the surrogate model. Sure. You can do Monte Carlo of Monte Carlo, why not? In the end, it increases the effort you have to put into your surrogate model or the amount of parameters he knows or it knows about. in order to give a reasonable answer to this question. So if you have an epistemic uncertainty in something where you want to propagate this through, then obviously your surrogate has to know that this is a parameter that has an influence on the result. Sure. So if you do this for math and alpha, and that's what you build the surrogate model, and now you say you have an epistemic uncertainty in surface roughness, for example, or surface shape, then the surrogate model is no good whatsoever because it simply doesn't know about it. If you, from the beginning on, incorporated this in the surrogate model, then it might still be the right tool. And then it's probably more a question of practicality. Do you build one surrogate model that covers it all? Or do you wrap the surrogate models in surrogate models? I don't know. What's especially the scalability is unanswered. But from a practical point of view, you can obviously draw samples from it.
Right. So I think these are kind of the areas I would say at the forefront of the first application areas. These ones where your problem is relatively well bounded, and dynamic shape design is still on the periphery of that relatively well bounded, but these are the opportune areas of using these techniques and UQ to look at robust design applications. I definitely see this as a method, and not just in robust design. I've also used similar approaches for margin setting. So how do we actually use these uncertainty approaches to determine what margin we want to apply to compress the design phase and to balance this uncertainty versus the risk of redesign.
And here you mean, okay, so here you mean margin not in the sense of safety margin,
nope,
but that redesigning.
Yep. Margin. So we've applied it to loads.
The freedom of exploring different options within but at the same time keeping to something that is not going to drive the cost up.
Yeah. So
at the end of the
for example, in something that I did in the 330 Neo, so we typically do this anyway. So we put margins in the design. This is typical in all the aircraft we've done. At some point, you put a margin and say, I'm going to design basically my structure to a slightly higher load level than we're predicting today.
Right.
That means that as the aircraft evolves and some of the risks materialize, as long as I can stay within that margin, everything's good and everybody can continue working and designing the aircraft. We're decoupling it. Okay. So you're then in that margin application, you're trading the cost of adding that margin. So you add weight, but you get the benefit of you don't have to redesign, or you don't have the risk of getting towards the end and not meeting your entry into service, or having some costly redesigns or whatever else that you've got to re-update. So this is a business kind of margin is applied for almost the business phase. It's kind of a case, yeah.
Perhaps tangential question there. Can you then go back once you conclude your design? Can you go back and you say, actually, I didn't use up all of the margin. Can I strip some of it away?
Correct. This is what you do in batch policy or updates of aircraft. So you can, in later aircraft, if you have some margin in the structure, we'll do a derivative. We'll do an aircraft. If you put margin in and then you find, okay, now we've done all the testing, we've qualified the aircraft, actually we've got a few % of extra margin in there, we might put a bigger winglet on, or we might do something else to improve the performance. So this is typically what we do with improvement packages along the aircraft. As over the years we will build in, and we will gradually use up that margin. So it's not gone to waste. It's waste for the first few aircraft that allows us to make it quickly and meet our entry and service targets. But after that, we will, or we can, use up some of that in derivatives.
Thank you.
A good question. Does it mean that you're allowed to put winglets on an A320, which initially had none, without redesigning the central wing box? That's the margin you can pretty much use up. All right.
Okay. Any comments or inputs? People online? Oh yeah. I mean, I didn't see that. There are any questions? Anybody? Yeah. Well, let's see who's still here. Yeah. Okay, so we still have a fair amount of people online. If you would like to ask something, please unmute yourself or comment. I see that Morten has asked something.
We don't have full discussion.
Yeah.
It's an hour ago.
It's an hour ago. Okay. Okay. Okay, so interesting, because it was not clear to me what the scope or purpose of the research is. Okay. Suggest it should be around performance, but simple QoIs only. And it would only be good to have at least one use case, could be generic in nature, to provide application focus for the research activities. So if I understand the comment correctly, he is talking about a more practical use case to demonstrate this on, or?
He probably wants to see some specific use cases.
Yeah. This is very much what we are after as well, so yeah, okay. Yeah.
Maybe a comment to that. I don't know if you're aware, but at least for aerodynamics, there is the AIAA UQ challenge problem, which is fairly new. And the idea is that you can use your UQ or your propagation tools on a simplistic examples they provide, XFoil. But there will be cross-plotting and comparing of results and evaluations and so on. So if you're interested in that, you can either go to AIAA Engage and pretty much join the group, or you can contact me at the end and I can add you to this. It consists out of few different aspects, like aleatoric uncertainties on inflow conditions to XFoil, but also epistemic uncertainties on, I think it's the control surface deflection angle, so you're not entirely sure. So there is a bit of free play. I think that's what it relates. And it comes with an overall engineering question. So something like, these are the design targets. Would you make the decision yes or no? And with what credibility, in order to see what people provide as an answer to that. There is also a paper existing to that, and the idea is to have a special session on that in SciTech 2024, so next January. So abstracts would be due in summer. At least if you're from the aerodynamics field, that might be of interest. There are a few interesting or bigger partners in there, like Boeing and NASA, Lockheed Martin, if I'm not mistaken, MBDA, GLR.
I'm aware of it, but I need to join them.
I don't think so. At least I haven't met anyone. I think Uwe followed a few of the very high-level discussions, but he never joined the technical.
And we should just to add to that.
Probably.
Just to add to that, we are. I think we're expecting the next monthly meeting, the European one. Still, there should be a slot at some point.
So far, yeah. It has been pretty American-centric. So they had very friendly. So it has been very centric about American people and their time zone. So if you wanted to join their monthly call, you probably stay up long or wake up in the middle of the night. So there has been the idea to make a European counterpart to that. But there was the question, what's the interest in it? I could provide a slot, like a monthly meeting to exchange on the problem and to move forward together. But if it's only me sitting there, it kind of feels like a wasted time once a month. And then, yeah, we're currently starting to spread it. So feel free to reach out to me in case there is an interest, and then we can have a discussion. Either we move the US slot so that they have to get up early and we stay up late, or we would try some plus on a European side.
So I'm interested in getting more involved. I was kind of used to the area. So support.
Feel free, we can change a few.
Okay. Anybody else? Any more comments? Anybody wants to share anything extra on these points? I would really encourage you to share your opinion.
But yes, it's time. It takes time and education and everything else.
What do you think is the main problem? They don't understand, or they think the upper limit is too conservative, or
How do I believe it? How have you validated this? Good question. How have you validated this? Well, I haven't.
But that's quite a hypocritical question, because if you go and ask how to validate your deterministic simulation, so yeah, look at this ideal slot.
Yeah. Well, we have validated our ones on previous aircraft, and then we get the results and we draw a thick line
Exactly.
through them and go, yeah, that's good enough.
Right.
What we do.
Interesting.
I think it's understanding the input and knowing what you show and what you can do with it.
Yeah.
And if I'm honest, I'm still struggling myself with a standard deviation around a pressure distribution. I don't know yet
What it means.
what I can physically derive from it as an engineer. And uncertainty is an uncomfortable position. So it's way easier if you have a line or a number and you say yes or no. While if you started with these distributions, then it becomes more complex and it becomes more challenging. And I agree with you, it's also an education thing. I mean, the question about the statistics course, there was 2 probably. And if we want to move towards uncertainty in a consistent fashion throughout design and throughout activities, we probably have to train the next generation of engineers from the beginning on to be aware of these things. So I think it's an effort that starts at university and does not start at an industrial level. So if you've done 10 years at Airbus, it's probably too late to convince you that uncertainties are an added value to this. You are already convinced. No, but and it's the same for me. If I go with to the natural laminar flow people, they could tell me that the design is okay. But I spent hours and hours and hours about the meaning and how we got there, because the whole concept didn't make sense to them. And it was very tedious, and I still don't think that I have convinced them.
So it depends on what you're trying to communicate. So, and who you're communicating to. So if you're communicating to a decision maker, they don't necessarily want or need to know all of the detailed statistics. They may need to know that someone that does know has looked at it and they're happy. It's like qualification is like, okay, somebody has understood this and they're okay with it. But ultimately, they're like, how does it impact the decision I need to make? What are you telling me?
Yeah.
How does it impact what I need to make? How have you validated this? How does this benefit me in making a decision?
Very much interpretation issue.
Yeah.
Because it makes it worse, doesn't it? If you're saying, I don't know the answers.
Yeah.
And decision makers don't want to hear that.
Yeah, sure.
So
They want to know this is the answer. Okay, I agree with you. I trust you. I'll go with that.
Do you tell me the answer?
Yeah.
I mean, you kind of pass the responsibility up.
Yeah.
I mean,
Yeah.
right now,
Yeah.
it's you as an engineer go there and say, we did all the analysis, it's fine. And then the guy nods and says, all right.
Yeah.
But if you go there and you say, we did all the analysis and we are quite certain that it's going to work out, but there is a probability of failure. Now it's down to you to decide.
Yeah.
Then you pretty much pass the decision that you always did before up to the higher level, which probably doesn't work.
Which we use to give assurances to things that are going to go well, right? You've made an assessment, you think it's going to be fine. Well, how sure are you that it's going to be fine? Are you absolutely sure? Are you 100%? No, of course, you're not 100% sure. How sure are you? That's what uncertainty tells you, right? And the other way, well, it works the other way too. I'm tired.
I had an issue. This was like 10 years ago. We had a system and we did 50 flight tests. And there was this issue that was happening, let's say almost never. And then we sort of fixed it and we changed the valve. It becomes which became more robust. It stopped happening. Then management said to me, is this never going to happen? I said, well, this valve is significantly much better than the previous one. So I don't think it will happen again. Based on our 50 flight tests, the data shows that it will probably not happen again. 2 weeks, 3 weeks later, he comes killing me on my desk. He said that's never going to happen. I said, based on the flight test, and I almost got killed. And then I looked, then how did this happen? There was nothing. Someone did a ground test
with parameters that are well beyond flight test, and on those parameters, that happened. But he didn't end up finishing the meeting, understanding that was a ground test and the parameters are over any possible flight test pressure oscillation or something like it. But having this sort of, if we could showcase to the decision makers, to the higher management, the data where it shows that the probability of some nice plot that can, okay, this will happen in 0.1% or 1% of the time. That is best, and that's better for us, because it's better for me to send him a plot saying that this shows that there is 1% of chance that this happened, because it's even easier on the communication. I think I'm not used. I hardly done that, but using this sort of probabilistic analysis, plots, really nice plots. I've seen some nice plots today. That is really helpful to communicate with higher management, and it covers ourselves as well.
Sure. It just depends on if you're talking to technical people, then yes, they've always understood that results are not perfect.
Right.
There's no such thing as certainty. But if you deal with kind of people that are not technical, that are kind of the managers, the budget holders, the finances, they're used to just having people telling them that it's okay. You know,
Sure.
it's the okay, rather than it might not be. What do you mean it might not be?
Isn't that what Philip said though? Isn't it?
Yeah, it's the same thing.
The decision maker is not the decision maker.
Yeah.
So it's just,
It has a second effect that it saves you, because when things go bad, it comes back to you. And if you have an email showing a plot that says, okay, there's 100
I told you.
and one there, it saves you because it's there.
Yeah.
Because by the end of the day, when things goes bad, it goes bad on the change.
Okay. Did you want to?
I don't know. I just try to understand a little bit. So the decision maker probably will be presented. We discuss about uncertainty vs the factor, the safety factor. So you have the weight of the structure is going to be X, with the safety factor is going to be 30% less, with 95% probability of being okay. And you say that if you present that to the decision maker, they will probably go with the safe factor because why take any risk? Or are we that? Okay, okay. All right.
But maybe more on kind of design decision or design decision. It depends on the decision makers.
Okay.
It really depends on the decision makers. Some are accepting of this.
Okay.
Some are not. In fact, I'm going to tell you a story. I'm not naming any name. So practicalities or uncertainty in the decision-making process. Okay, a practical example.
Mm-hmm.
So on an aircraft program, on language one of my colleagues did a very early uncertainty, a sensitivity study on something. Okay, and it showed that, okay, there was something we had to decide. There was an uncertainty. Did a sensitivity study and said, look, okay, there's a variation in this. I recommend we put a margin on that because of all these uncertainties. Mm-hmm. And the decision maker went, very nice. But I've been in Airbus 20, 30 years, and I know that you guys in the loads department always keep something in your back pocket. So there's always a margin there. So I'm going to ignore that completely because I know you've got that margin in your back pocket. So I'm going to go with the other one. Okay. So he's taken that, listened to the evidence, mm-hmm. taken his previous knowledge of, oh, I know they've always got a margin in their back pocket, and they're not telling me the full story. And I'm going to challenge them because applying that margin would have cost something that he didn't want to pay. It would have impacted the aircraft performance and whatever else, and he didn't want to go there. So I'm going to push that back onto you and say, actually, no, I'm not going to absorb that. You're going to absorb that, and I'm going to keep the project fine. So I don't believe it. So that's, no matter how good your analysis is, mm-hmm. there's still a decision maker, which is a human, which has their own biases, previous experience, previous preconceptions, and everything else. So no matter how good your UQ is, there's still that barrier to go to.
Because in fact, he's following a target.
Absolutely.
So he knows he has a challenge. You can't just accept what you say.
Exactly.
That's a challenge of back.
Right. Yeah.
To get that challenge.
Is there some basis?
Yeah.
Yeah.
And it's there to model the uncertainty about how they're going to respond
Right.
to it. Factor that into the surrogate model.
I mean, the way
Yeah.
the way people you get people to stop gaming you is to tell them the truth, right? That's like, yeah.
But the first two rounds of that game, you lose.
The question, you know, the main question you see is without cost infidelities or, you know, things falling out of the sky. I don't know that it's possible because if you think about it, what engineering advances have been made without that payment? Very few. There's always a payment, right? With new technologies, boilers, rat lights, rat traps, everything we make has, you know, a learning curve that don't get me started on cars.
Maybe the philosophical question is, can Airbus afford doing that as a company? So maybe the whole aerospace industry as a whole can do it. They can deal with failures, but there is always someone absorbing the failures. And from a business perspective, the question is, can you afford the failure?
Very good point.
I don't know.
I think the last question is perfectly clear, actually, right? But the last, it's either you get them to do it because there's a financial advantage for the company, or you shame them into doing it. One of those, maybe a combination of both.
Would maybe, I don't know, looking at introducing UQ in something like the manufacturing processes initially rather than straight in design be a scope for, like, look, not that you can't have fatalities coming from trying to change manufacturing processes, because it's possible, but you're reducing the scope to something that's maybe more manageable, where you can demonstrate a process, and then if you can demonstrate a benefit in that sense, there may be a point at which you say, okay, well, it's had these benefits in the manufacturing side of things. Maybe now we can start thinking about, okay, maybe we can trust this enough to start thinking about applying it on the design side. Yeah, exactly. It's all part of the quality.
It's recognizing beneficial. No.
It's not to the extent of like the tools that are available, but it is a process that's in place. Yeah.
So, not to abort the discussion or abbreviate it in any way, but maybe we should think put together this day. So, gratuitous applause.
Thank you. Well, we've promised 2 more on the door, so it's guaranteed to not be the last.
So thank you really for organizing.
Thank you. It was a very good discussion, set of discussions, I think, and useful and valuable material shared. I hope to keep that general interest growing, or if not growing, then at least at a plateau. Yeah. So that we can really, I mean, I don't think it's beyond our capacity to find a way to apply these things, provided, you know, that added value argument, which is, nobody can argue with that. But I think if you think about it, there are things that will be gained by applying UQ to things. I think we can close the day. Yeah. Thank you very much for to all the participants, to all that shared their presentations. Wouldn't be possible without you. So what I plan to do, once Simon stops that recording, once I get it, I'll probably chop it up into more digestible pieces, try to clear some of the noise, and potentially upload it somewhere that you can access. A plan was also to use whatever feedback we get from here to update the uncertainty propagation report that we wrote under DAWS. Certainly a lot of things to go in there from today. I am going to recirculate the link to that report. It's been vetted by our bosses as what do you call it, non-confidential. Yeah. So yeah, we can distribute that. Other than that, I think that's it for today. Safe trip, yeah. Have safe trips back home. Thank you.